Across the vast expanse of the cosmos, there exist dazzling displays of cosmic fireworks known as starburst galaxies. These stellar metropolises are ablaze with the light of millions upon millions of newborn stars, shining with an intensity that dwarfs even the grandest galaxies like our own. They are regions of intense star formation, where gas and dust, the raw materials for stars, are consumed at a prodigious rate. Imagine a cosmic kitchen where stars are being baked at a pace hundreds of times faster than in our own Milky Way galaxy. That's a starburst galaxy. Our own Milky Way galaxy, a spiral of a few hundred billion stars, forms stars at a rather leisurely pace, perhaps 1 or 2 new stars each year. Starburst galaxies, on the other hand, are veritable star factories, churning out hundreds, even thousands of stars annually. They are cosmic outliers, pushing the limits of star formation and providing astronomers with invaluable insights into the processes that govern the birth and evolution of galaxies. What triggers such a frenzy of star formation in these galaxies? The answer often lies in cosmic collisions, grand celestial dances where galaxies are drawn together by their mutual gravity. When two galaxies collide or even pass close to each other, their normally placid reserves of gas and dust are stirred up like cream in coffee. The gas clouds, now compressed and agitated, become fertile breeding grounds for new stars. It's not just the initial collision that fuels the starburst. As massive stars are born, they live fast and die young, exploding as supernovae. These stellar explosions send shock waves rippling through the surrounding gas, further compressing it and triggering even more star formation. Imagine a chain reaction, with each supernova setting off the birth of countless more stars. It's a cosmic cycle of creation and destruction, playing out on a grand scale. Ironically, the very process that makes starburst galaxies so luminous can also hide them from our view. The intense star formation produces copious amounts of dust, which absorbs visible light, obscuring these stellar nurseries from optical telescopes. But don't be fooled. While hidden from our eyes, starburst galaxies shine brightly in infrared light, a type of light invisible to human eyes but detectable by specialized telescopes. In fact, starburst galaxies are some of the most luminous objects in the infrared sky. This is because the dust that obscures visible light actually absorbs it and re-emits it at longer infrared wavelengths. Think of it like a cosmic cloak. It hides the starburst in visible light, but it glows brightly in infrared. This infrared glow allows astronomers to peer through the dust and witness the full fury of these star-forming powerhouses. Despite their intense activity, starburst galaxies are not eternal. Their furious pace of star formation is unsustainable, like a bonfire that burns brightly but quickly consumes its fuel. Within a few 100 million years, a mere blink of an eye in cosmic terms, the gas and dust that fuel the starburst are exhausted, and the galaxy settles into a more sedate existence. However, the legacy of a starburst is profound. The intense star formation leaves behind a population of young, massive stars, which in turn evolve and enrich the surrounding interstellar medium with heavier elements. These elements will eventually be incorporated into future generations of stars and planets, seeding the cosmos with the building blocks of life itself. Moreover, starburst galaxies are often home to supermassive black holes at their centers, which can also influence the evolution of their host galaxies. By studying these enigmatic objects, we gain insights into the processes that shaped our own galaxy, the Milky Way, and indeed the entire universe. They are cosmic laboratories where we can witness the awe-inspiring power of gravity and the intricate dance of birth, death, and renewal that plays out on a cosmic scale.